Labs. My name is Ben. Hello and good morning. Welcome to the micro soldering show. And today in the morning we just start by an iPhone 8, which was mailed in for data recovery. It just shut down, doesn't work anymore, and only shows the Apple, and there are many important pictures on that phone. So the customer wants to have a data rescue. I try my best to get the data. So just one moment, I have just to answer one question. One question I have to answer. Just a question came in on Facebook and I really answer fast normally. Okay. So many. Okay, let's go. We just start by disassembling the phone. We go on hands. And then we just start by opening the phone and having a look where the problem could be. So, getting the screws out. Then I just need a cable. A lightning cable would be great. 1 second. Lightning cable would be great. And here we got one. Next thing is that we just have to get one device which I have here. Okay, just getting into the recovery mode with that iPad, so I can just do a restore here. Okay, so now we just check that phone. What's happening? Okay. Let's see, we see a battery logo, so something's happening here. For me, I read the form about that device and I thought it could be the NAND. Okay, and that's just a really hard water damage. You see that? It's full of water and the customer didn't write anything about that. Okay. So let's see if we can help here. So if the customer doesn't write anything about water damage, it's just normal that I have a look for the charging current. But I just don't understand why you don't write, I have a water damage and I need my important data. There are many pictures on the phone, there are many data on the phone, I don't have a backup, please help me. Then it's just no problem. But if you don't write, could be bad, because I tried to charge the device, it's full of water. That's not good. So always be honest, and it's not a problem to have water damage. that's really not a problem. But you have to write, okay, I have water damage. Can you please help me? Yes, I can. Normally I can do. Okay. I just open up the device. Getting out all the screws. Everywhere you can see screws, just get them out. And after that, take out the board, clean it, have a look on power supply. Just want to see for shorts. And the first thing I see is that we have a short about 60 milliamps, and if I try to boot, it's not a normal value on the power supply. So let's see under the microscope, what do we see here? An EMI shield. Yeah, clue sticker. Just get it off. By the way, Apple told the customer that the phone isn't repairable and data aren't savable. That is what he wrote on the form, but he didn't wrote anything about the water damage. Okay. You see only some corrosion here in this area. This looks really clean. What about around the NAND? Okay. And what about down there? Okay. Doesn't look as bad as all. Some corrosion here in that area. Some corrosion here. Red water marker. Getting at the gum. The gum away here. Okay. Just cleaning a little bit here. I just have to see. Okay. No problems here, no problems here. What about chestnut? Chestnut is looking fine, no corrosion. Okay. I would say we take the front shield off. We take the front shield off. and just having a look if we can see something there. I just take the shield off. Okay. Get rid of the shield. Take away the thermal paste and having a look straight under the microscope. And before that I start ZXW. Just waiting for the software. Software doesn't want to start. Just give me a second. I want to see why. So now the iPhone 8. Intel version, yes. Just waiting a short second, please. Now the software wants to work, okay. So, okay. Oh, now we go straight under the microscope and we just have a look if we can see some corrosion here. And it really looks clean for me. So, visual inspection is done. Just having a look again. Okay, we still have 30 milliamp short. If we try to boot, we have jumping up and down. The value is going up 100 milliamps, down 20 milliamps, up 90 milliamps, down 50 milliamps, up 100 milliamps. Okay. For me, if I see something like that, it's often related to an I2c problem. I will just open up the schematics and show them to you. So, window capture, schematics, and I want to show you schematic. Okay, here, nice schematic, and that's always the way I go. If I got jumping numbers up and down, then I just check the I2c lines. So we got I2c0, I2c1, I2c2, I2c3, and I just check them in diet mode to see if there is a problem on one of the I2c lines, and I check it at the resistors. So I just do that a little bit smaller here. And then we just should go to that here, I2c1, I2c. We start at I2c0, then we open up ZXW, and we search for R1400. So, okay, I show it to you. ZXW, window capture, ZXW, and we start by open ZXW here. Okay, so I just search for that for a resistor, for the first resistor under I2c0 and the second one. So SCL and SDA on I2c0, I check 1400 and 1401 in diode mode. 1400 and 1401. So give me some orientation. Okay, I have to use a brush. Where's my normal brush here? So you see that's under the overfill, so perhaps we start on the 1, 1410 and 1411. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 8. Okay. Okay. One, two, three, four, 5, 6, 7, 8 in diode mode. Okay, should be around 300 millivolts. That's okay. But what, it's the second I check, really, I check now the 1410, and we should have about 300 millivolts here, and the other side about 350, 400. So, and what we got here? We got open line. It's open line. What about this side? We got an open line problem here. So I hope we got no lags now because of the many windows we have opened. So I show it again to you. We have a problem here on the resistor. Oh, give me i2c 1 resistor 1410, and we got open line here, and that's just not normal. So I think we should change that resistor and then see what about the boot. So we close that and that. We count to the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That one here. Okay. So we go to the preheater, and we are working directly next to the CPU. So we should be really careful. Just mark it with a little small point of flux. One, two, three, four, five, six, 7, 8, 9. So, and I don't want to damage anything here. One, two, three, four, five, six, 7, 8, 9. That one. 1, 2, 3, 4. Okay, we need soldering station which is on for doing things like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Come out, baby. Okay, here we are. Come, little resistor. Okay. Now we just clean. Okay, this looks good. Now we just take another iPhone 8 board and we just take the resistor out of that. That's a nice repair, really. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's hope that we get it out fast and easy. Here we are. I just want to take a photo of that tiny little resistor. Okay, now we just get this resistor down here. Okay, just a little bit more flux. Okay, should be good. So first I want to test, and after that I seal it a little bit. Okay. So what do we need? Where is the microscope? And we need on hands. Okay. So here we got the board. No, the screen is hardly water damaged. Don't want to use it, but I want to see. It's hot. I want to see what about a boot now with I2c 1 well connected again. Oh, 137, 200 milliamps. Go up, please go up. 184, 300. I would say that could work. I just take a screen. iPhone 8 test screen. Is it okay? I hope. And please give me an apple. Please give me an apple. Give me an apple, please. Okay, no image. Or just a broken screen. Could be too. And again, because the value on power supply is good. And boom! We are back to life again with our iPhone 8 after water damage. Customer didn't tell us about the water damage, and a broken resistor. I didn't saw any corrosion on that resistor. I don't know if the customer has personal data on the phone, so I just want to wait a second for that. Here, still the apple. But you saw, I didn't saw a sign of corrosion at this resistor, nothing. But we checked it in diode mode and we were open line, and that was not correct. So just replace the resistor. I didn't do any measurements after replacing the resistor. I just wanted to boot the device. So okay, we still got a loop. What is he writing? Okay, so I would say we just here I don't see anything of corrosion. On the power button I see corrosion, but I just need to test housing. For doing that, what I want to do now, because the phone is booting up again, that's not the problem, and now I just want to do an update. So we need a battery for doing that. Do we have an iPhone 8 battery for test here? Yes, we have. Okay. And I just want to connect this screen. Okay, screen connected. Connect the battery. So no more jumping values, just normal boot behavior on power supply. But still one problem, and the problem is we need to do an update. Waiting for reaction. Can we do an update on this phone or not? Okay, we need to go into the, we are not on the iPhone 7. We have to press up, down, no, not again, up, down, battery off. We could use the box too, so that's much. Oh, I clicked something on the keyboard. I hope there isn't changing anything at the video now. It wasn't my intention to do that. So okay, we use this view box to get it in the restore mode. Yeah, this works. This works. And now I just want to update the device. I hope that it wasn't too long in the boot loop, because if you got damages like water damage or things like that and the device starts looping, it's really important that you disconnect the battery, because if the loop is too long and it loops and it loops and it loops, you will get an error later on the update. You will get error 14 or things like that. And that would be game over in this case, and you couldn't save the data. So let's hope that the phone wasn't too long in a boot loop, because you saw as it came here, we couldn't boot. We just had jumping values up to 100, down to 20, up to 90, down to 15 and things like that. Just jumping values at power supply. That was related to a disconnected I2c line. So we reconnected the I2c line by replacing a resistor. We took the resistor out of a Dana board, and then we saw that the value is okay again. We have normal values on power supply, but we have a boot loop. The Apple logo comes and it goes, and comes and goes. And that can be related to disconnected I2c line, or caused by the water damage, caused by material fault, whatever. And if the device goes to the loop then, and it is too long in the loop, the problem is that you can that you could get a problem with the data, with the NAND. Okay, what I want to do now, because it really takes a lot of time now to update the device and check it, I will update the device, and after the device has been updated, I will check if it works, and if it works the video comes up, otherwise I just don't get up the video. I hope you like it anyway, because I don't have the time to wait such a long time again. I just wait now until the update has done, and after that I just upload the video if all works nice. Okay, I'm out. I hope you like the video. If you want to learn things like that, you can do that easily at the Waterdamage Repair School Germany. If you are working at the repair industry for smartphones and tablets, you can join our Facebook group, Smartphone Repair Group Germany. Yeah, I'm out. Give me a thumbs up, like it, and boom, back to life again. Goodbye. Here's Ben.